Okay, so last week we discussed sites as a farm or garden ecosystem. Specifically, we looked at defining the ideal site, or at least how I define it. We looked at plant requirements to make that a site ideal for them. Soil basics to understand why we are doing any sort of soil test or why soil even matters in the first place for growing plants. And then we went over lots of different parts of site assessment, defining it, different measurements you can take, different tools, and how all of that just builds up on one another. So we discussed these topics in the context of food systems, and we focused in on the role of the farmer, which is highlighted here in green. And today we're going to keep that focus as we cover creating and caring for gardens, which is our part 4 last part. To do this, we will look at what to do after conducting a site assessment to establish a garden and learn a few ways to care for your garden through several gardening practices focused on regenerative agriculture, including how to identify and hopefully troubleshoot some common plant problems, although that's really a practice. And lastly, in addition to answering your questions, I will share some ways that you can learn even more about the topics we discussed throughout the series. And if you have other things you want to learn about, you can let me know and I can see what I know about the topic you're interested in. So as you notice, I didn't put plant ID on here like I had in the past session as a review of this week, and that was because I really want to be able to focus in on the things that everyone kept mentioning to me. However, I will send you some information on plant ID if you want to learn more about it and start to get into it. So again, I'll just drop the link to the poll everywhere in case new people dropped in. So with that, let's get into it. So last week when we covered site assessment, we defined it as something. How did we define site assessment? Interesting. So as I think 80% of you said, yeah, 82 at this point, a site assessment is a set of tests and observations to determine the viability of a given farm or garden or site. I put that question in there because it was actually a question that people missed a lot, and I wanted to make sure that it's a concept everyone understood. Last time, a lot of people chose this first answer, which that's what I define as an ideal site. So you're just conducting tests and observations. So the site assessment, to review again, considers microclimate, which includes precipitation, sun exposure, and so on. It also considers space, so soil, accessibility of that site, resource availability, and the size. So you went over a lot of tests one can conduct, like texture, pH, and compaction for soil, observations one can make, like looking at sun exposure, and the data one can review, like precipitation and temperature averages, all to understand or assess the potential of a chosen site. But what happens next? Like, what happens after you complete these different tests and make your observations? And which of these tests are essential? So there are some steps you can take. You don't necessarily have to follow them exactly in this order or the way that I'm presenting them to you, but this is how I think about them for clarity. So you can map out the most relevant spatial data and other notes that you find to be critical about your site. Then you can reference materials that have accurate information, which includes resources from Extension, like Cornell Cooperative Extension for New York State, government agencies like the USDA and all of its many departments. Universities will have a lot of free information on their sites as well. Seed companies will have lots of information, like Johnny Seeds, which we'll give an example of one of their products today, actually. Intergenerational wisdom, I think, is something that's very important, that's often looked over, but that is a good source of information too. And also your own consistent experience with something. You don't want to doubt or miscredit or discount the information that you're learning from your own experiences as growers. But can your site accommodate what you want and need is the last thing, based on everything that you figure out. So in this example, just to show you what that process looks like, here are some goals from this like fictional group that I created. So let's say that you want to create a small vegetable and herb garden, and you're focusing on, and again, on those regenerative ag practices. And one of your goals is also to use this food that you're growing for your local mutual aid group. And a mutual aid group is just this group of people within a community who are like sharing resources and supporting each other to help each other sustain and their selves and also thrive. So it's that idea of putting the power back into the hands of the people. And let's say you also only want to use it during the growing season, so you don't want anything that's extending the season, that's not something that's very important to you, and you have this budget of, let's say, like $1,000, everyone's pulling together some money to make this garden happen. And let's say also for this fictional garden, you want to grow plants with hardy stems like kohlrabi, which is to the left, and celery, and you want to grow fruiting plants like beans and tomatoes and peppers, and you want to grow leafy greens like lettuce, callaloo, and collard greens, and lastly for your herbs, you want to grow mint, basil, and parsley. Just making something up. So if we go back to our list of what to do after you do your site assessment, you'd want to draw a map with your data with these different characteristics. So what are some of these characteristics that we might place on a visual representation of our site? Labels. Can we get more specific? What are we labeling? Why am I putting sun exposure on there? Paths. I don't know what viewers connects to. Ponds, so like what natural features are there, sure. Water. Trees. Nutrients. Shade versus sun. Yeah, so I'm seeing a lot of good examples of things you put on there. So we actually will plot a lot of those different characteristics. So this is, again, something I just like created for our example, for our space. So one of the first things that you would do is start with just the size of the space, those largest characteristics. So, let's say your site is like 20 feet by 40 feet. So you can do that in, N feet, you can do that in meters, you can do it in whatever unit of measurement you want to use, as long as it's consistent so that you understand what's going on there. And then you also want to think about the shape. Like this one, I made a rectangle just for simplicity's sake, but your site might be any sort of shape, and you can draw this out using a pencil or on a piece of paper, or using some type of like whiteboard or whatever you want to do to make this map so that you can reference it. You also might want to put entrances on the site. So if it's something that's enclosed in a space, you want to be like, oh, I can get into the site through this way. So when you're plotting other things on it, you're not going to plot something right in front of where you're supposed to be entering the site in the first place or leaving it. You could also put water sources on this map, which I think you definitely should, so you know how you're going to be able to water your plants or really use any sort of water for anything. Then the second thing you can start doing is putting in those broader characteristics about like the site itself. So people were talking about trees. So if there's a tree on your site, you can put that on there and have like a label for that and have a key so that you know what all these symbols mean. Because it won't be able to necessarily label every single part and understand what is going where. So for this map, I decided to do it based on primarily sun exposure. So if you're seeing up here in this first corner, left upper hand corner, I started with like partial shade. Like let's say that there's like a tree outside, right outside the boundary or a building. So there's like this dense shade that's happening closest to that shade source. And then as you're moving away from it, you know, there's less and less shade until you're getting to full sun. And then also when you're doing your soil test, you want to do multiple parts of the site because different parts of the site might have slightly different soil textures and soil characteristics. And another thing you'd want to do is put your pH there, and also any other things that you're noticing about the site that don't necessarily need to go directly onto the map, but are relevant to the map as a whole. So for this example of this fictional group, the pH of their soil is a range. You can also be more specific in putting your pH in different places, but that's not always necessary. It might just crowd your site map. So I'm saying it's between 6.5 and 7.5, so acidic and a bit neutral, a little bit basic. You also, like I said, can list other things that you're learning from tools if you want to write about precipitation or whatever. So for this example, I'm assuming that we're on Long Island on like the northern part. So very basically, that's usually like a USD A hardiness zone of 7A, receives about 40 to 52 inches of precipitation annually, sits at an elevation between 0 and 360 feet, and has about like a 0 to 3% slope and is fairly windy. So there isn't anything extreme happening. These are just the basic characteristics to consider when we're looking at this next part, which is crops. So when we had our list of things that people in this fictional group really want to see in this garden that they have or are trying to have. So what you can do is, like I said before in that part 2 of after plotting things on your map, is seeing what things can you reference to understand those numbers a bit better or those facts a bit better. So if you're looking in terms of crops, you can say, well, if I really want to grow specifically bush beans, I can go on to Cornell University's like general vegetable growing guides, and these were providing like a broad range of information about different common vegetables that are grown throughout New York State. So let's say you want to use this just to start, and you'll learn like, oh, so bush beans and like full sun, they want soil that's well drained and with consistent moisture, and you want a pH between 6 to 6.8. It has a height of 1 to 3 feet, and it spreads out, so it's like width essentially is 1 to 2 feet. And you have lettuce that has slightly different needs. Its pH range lower bound is a little bit higher, and it's more sensitive to lower pH. It also wants well-drained soil, but it also can tolerate part shade. So when you go to look back at your map and you want to do this for as many crops as you can, just to see what part of the site they'll be best suited, you might have like bush beans that you have a new symbol for it. And let's say, well, since we saw last time that it needs full sun with the pH between 6 and 6.8, well, we know that's the range here. And again, if you want to be more specific and knowing that this is like a more suitable range on this part of the site, then if you want to put something directly into the soil, then oh, well, I can put this here, and each of these boxes are 2 feet in width, so I know I can fit about like one plant every so often. And then it helps you figure out like how much space do you really have, because it might look like you have all this space, but then when you go to look at the size of how big your plants are probably going to get, because you don't want to crowd them, you realize, well, maybe my space is not nearly as large as I thought it was. But you could also use this to see, what plants will be, best suited next to each other, and how much space is that taking up? Is that awkward? But is this everything to put on a map? What about the crops that don't work in your soil? What if you have something that wants a pH of like 8 or something like that? Or what if the soil needs to be closer to like clay? Like what do you do then? And then how will we get to all of these plants? So you can think about your garden plan, or you can think of it as a design. But when I say design, I'm not talking about, thinking about elements like emphasis and balance and scale, which you can consider all those things if you're looking to have also a very strongly visually appealing garden like the one on that's on the photo on the left on the slide. But I'm really thinking about the utility of a space when I talk about garden planning or designing your garden in this specific way. So instead, I'm thinking about how you will grow your plants in terms of physical space. So how will you contain your plants? Will you put them in raised beds, which has the appeal of not having to use the soil that's there if you build up enough soil in that bed, because plant roots go down to certain depths. Will you put them in pots because that's easier and can utilize maybe some concrete that's on the space, because every part of the space doesn't have soil that you can use, or if the soil is contaminated, you don't want to touch the soil at all. Do you want to put it into some other type of like hydroponic setup? Like these are all the things that you can consider with using the space. And again, thinking about the parts of your site that aren't favorable to your the plants that you want to grow, but don't necessarily need to stop you from growing them. We also need to think about being able to access your plants. So if you're thinking about people, are those paths that you're creating on your site wide enough for people to get through? Someone with a wheelchair, someone with a stroller, can all of those people get through that space? If you have a wheelbarrow that's really large, how big can your wheelbarrow even be to get down those paths to reach your plants? And then once your plants are in the bed, like a raised bed, in-ground bed, whatever, if it's so wide that you can't really reach the center of it, then it's way too wide, and you need to think about, well, if I can't reach them, how can I take care of them? So you got to think about that. You got to think if there's room for support. So if you're growing something like tomatoes and you want to use stakes or cages, that takes up space as well. So you got to think, do I have enough space to actually support my plants that are growing really tall? And then if you're thinking about, again, like pots versus raised beds versus like all these other ways that you can contain plants, can you access them easily that way or consistently? If they're all in-ground beds and you have back problems, maybe that's not how you want to have your plants growing, because then you have to bend down all the time to access them. Or if you have a bad knee, like you want to be able to consider all those things. And then again, thinking about growth habit, which is something I started to mention when thinking about just potting your plants, is how tall they're going to grow, and also what spread do they have, or some plants be shading other types of plants if you put them there. Will some plants be growing out so far that they're now inside the path? Did you consider that? And then there's timing. And timing is looking at when each of these plants grow. You can think about it almost as seasonality, because you don't necessarily grow every plant that you want to grow in your garden at the same exact time. So you got to think about staggering that, and how much can you grow in a given, like month or set of, weeks or whatever time frame you're looking at. And then lastly, although there's so many other things you can look at and get more granular, is cost. So if you have, you want to grow something that has a lot of, nutrient needs, or you have to do transplants because it's really hard to grow that plant by seed, then you need to consider having to pay for those things, to buy those things. And if you have a small budget, maybe you don't want to grow those things, or in the spirit of mutual aid, you want to share those things. Maybe you do a seed swap because, so-and-so has pumpkin seeds and they really want cucumber seeds that you have, so you can do a swap that way. If someone wants to donate something to you, like mulch, if you have tools that someone has, so you can think about the ways around that. Or if there's no way to access those things because you can't buy them, or no one has them to like donate or swap with you, then you might just have to forego it altogether, which changes your plan as well. So I'm only going to go through timing here just because, timing for this presentation. So, but I can also get into all of these things after if you really want to know more. And I decided to pick scheduling because I feel like this is something that's very important. So whenever you get like a seed packet, hopefully it should tell you how many days until that particular variety and particular plant will get to maturity. So being able to harvest it, whatever age that is. So that's the idea of having like this box here that's in red that's on the seed packet. And when it says days, it's usually meaning like days to maturity. So that's 50 days. So you might want to get like a spreadsheet, or you're taking out a chart if you want to handwrite it. And you have like all these lists of plants, you know, the variety, because plants, you know, you have like a straight species, but you might want a plant that has really small tomatoes that are yellow or something like that. That's what the variety is telling you. And you'll want to put your days to maturity on there on this list. So then you can take a look at more information about that particular plant. So I decided just to pick like a type of bean. So with here, you can look at the germination guide. So if you're seeing here, at minimum, it wants like 60 degrees Fahrenheit and at maximum 95. Anything outside of that, your plant is not going to germinate. And if you see here, the days to maturity is 54. So if you're looking at the temperatures, those are usually happening in like May if you're thinking about being on Long Island. So you're like, okay, now that I know days to maturity, like what is that telling me in terms of timing? So you can either count backwards and say, well, I want beans to be available in July. So 54 days is about 8 weeks. So you can count backwards and say, oh, that means I have to plant on the 7th. Or you can do it the other way where you're like, okay, I want to start getting, you know, plants going as soon as possible. So you might want to start on the 7th and then count forward and say like, that's when these might be mature. And then since you know, like these are how many days or weeks or whatever until my plant's going to be ready, well, maybe I want to have even more. So maybe, you know, on the 14th of this past May, I would have planted beans again. And then that's the concept of succession planting, where you're having multiple harvests within a single season because you're making sure that you're timing your plantings well. And something that I mentioned last week was the concept of growing degree days. So that's the concept of understanding that plants are in part influenced by how much temperature or how much heat, how much energy that they can is there for them to progress in their developmental stages. So instead of, or in addition to using these to plan out your days, you can actually see, will I actually reach those goals that I set forth for this garden by seeing like, have there been enough days that are above, let's say like 70 degrees for this plant to reach the next stage of development. So that's a way of just like tracking how well this process is going to go. Okay, so then once you have this for like every single plant that you're thinking about planting, you can put this in a spreadsheet. This is, or like again on your chart, this is one that I used in 2021. So I was just planting like, okay, I want to start transplants. I'm going to start those in like the late March, and I'm going to make sure that I'm able to transplant them and put them off into the garden at whatever other date. And then on the right here to the furthest right of this chart are the dates of when I'm going to directly sow things. So you can do that and you can make it whatever visual representation or like, you know, data sheet, whatever makes the most sense to you so that you understand what's going on in your garden. And you might also want to coordinate, you know, what day you're planting something or like when you're planting anything at all with where on your site you're going to plant it. So for example, if we're looking to the chart to the left or the diagram to the left, you might decide, okay, because there's so much like clay kind of soil here and there's a lot of shade, I might not really want to put something directly into the soil. So I'm going to put raised beds there. So I want to plant my beans. Well, beans are pretty high light, but I want to take like a low light lettuce plant because, you know, it gets really hot by the time I want to plant them in like July, let's say. You might want to put them in your raised bed with the soil that you want, and R1 at whatever date in July, for example. So you can make sure that your chart gets even more specified, or you have like a secondary chart that's a little clearer for you to see what's going where. Are there any questions about any of this that I mentioned about plotting anything before I move on? Kathy?
Yeah, I love you the idea of planting in raised beds. I'd like it if you could address the watering situation when you have a raised bed.
Yeah, so when you have well, I'm actually going to get into this later as well, but you just want to, you can have irrigation if you want, like you can have something like an irrigation system, like a drip or something, and make sure that it's, you know, not in the path where your people are tripping over it. But you can just take a hose to it and make sure that you're really drenching that soil. Because soil, as we were talking about, I think it was last week, has is going to, the water is essentially going to flow like through it, because the water is going from like the higher concentration to a lower concentration, plus it's literally being like attracted by soil particles. So if you're making sure that you're watering it for like deeply, that water is going to spread and your plants will be fine. But also with the concept of raised beds, if your raised bed is only like 2 inches above the ground, like that's great if your roots are very shallow, like if you're doing microgreens. But if you have something like a carrot or a bean plant where those roots are going down like 24 inches, like you have a raised bed and that's great, and maybe that's giving you like better access to the plant, or maybe making the barriers easier to distinguish between the bed and the path, but the roots are still going to be touching whatever's in that soil. So you have to think about that as well if you're like, I don't want to touch that soil at all. So these are all considerations to make, and I hope that answered your question or started to answer your question. Okay, cool. Well, if there are any other questions, please drop them in the chat. So as you can see, there's a lot going on with this map. So you're going to be changing your map, as you learn more and more. And maybe what plan worked last year didn't work as well next year. So you want to change that around too, so you can keep these maps for as long as they make sense. So once your plants are in the ground and you're like, the thing you visualize this became a reality, how are you going to take care of these plants? What are some good practices in the concept of regenerative agriculture that we covered in the first session and a little bit throughout the other sessions, to really make sure that your plants are going to thrive? So, of course, it's another pull everywhere question. So what are some of these, good garden practices? Ooh, mindful planting. I wonder what that means. Compost. Ooh, watering often. We're getting to that point. Weeding. No-till. Nothing else comes to mind? Okay. Well, we'll get into some of these. No chemicals. That's an interesting point that I also want to bring up. So we're going to, like I said, talk about those different things that people mentioned and brought up. But you could also think about all of these ways of caring for things. And of course, I can't get into every single, detail of what you can do. But a broad category would be soil care. So there's so many things within that, because you're thinking about soil being able to have those nutrients and getting water to your plants. And there's so much going on down there to support the life above the soil that you actively see the most often. So you can put mulch down like you see in this photo to the left. The lighter brown or like kind of tan is a bunch of wood chips that we had put down in a farm on Long Island. So mulching is really used to protect the soil, because if your soil is constantly exposed, there's a lot of erosion. We were talking about like those soil forming factors and how different environmental factors can impact the soil, and what texture it is, and how much is even there in the first place. And also minimizing soil disturbance. So you don't want to be constantly, interacting and bothering your soils, that concept of no-till. And also mulch will end up keeping in a lot of moisture, depending on, what kind of mulch you're putting down and where you're putting it down. So mulch is one of those ways to protect your soil and the plants. Anything can be mulch, if you try hard enough. You can use newspapers as mulch. You can use wood chips. You can use plastic if you want. You can use, gosh, there's just so much you can use as mulch. Like you can use like degrading leaves. There's just so much you can put to mulch an area. It doesn't have to be, something that you carried in that's like that red or really dark brown or black mulch. It could really be anything. although they all have their pros and cons. There's also amendments you can add to soil. So I know a few lessons ago we were talking about mycorrhizae, so that fungus that gets into plants, and they have this positive symbiotic relationship. So you can actually add those little different types of organisms to the soil to help soil fertility, soil life. You can add fertilizers to it. There are organic fertilizers, you can add compost, and all of those things are different types of chemicals. So when we're talking about things being organic, it's not a matter of not using chemicals, it's like what chemicals are you using and to what extent are they impacting your environment. Yeah, you can shred the leaves, but you don't have to, just looking at the question in the chat. Depends on what you're using it for. When you're breaking something down and you're shredding it, you're creating more surface area, so you're giving it a better chance to break down even further, which can be adding nutrients to your soil, which is a positive. But if you really want it to stay there, I mean, you can use the leaves, but they will eventually break down, which is what is part of the beauty of using things that are already decaying in your environment, so that's being recycled. You can do cover crops. So this is another thing that was mentioned during that first day that we were here together in this space. So that's the concept of putting plants down to help, protect the soil. So you might put down like, clovers that are nitrogen fixing. So now you're going to increase the nitrogen content of the soil, but you don't want to do that every single time. You want to pick plants according to the needs of the soil. So if you had something that was really draining in a particular nutrient, you can put a plant there that might support that, or at least not continuously drain that from the soil. And it's also keeping the soil from eroding, because again, you're protecting it, because the roots are actually like keeping that soil in place as well as the roots are keeping the plant in place. So that's what cover crops are doing. And then also, if you do something like winter rye, you can eat part of it if you want to, but you could also like cut that down and use that as a mulch, because it, as long as it's dead all the way, so then you have your mulch that you can directly plant into. Like on this farm that's pictured here, we actually did that in one of the areas and then ended up putting watermelon and sweet potato down within it. But again, you want to make sure that you like kill that altogether, because if not, you'll just have a bunch of cover crop randomly growing, which isn't necessarily a big deal, but if you're thinking about having resources for the plants that you're trying to grow and harvest in some type of way, you don't always necessarily want there to be a bunch of other plants in that area that may be taking the same nutrients, and then you're creating this unnecessary competition when things can be working in harmony with each other. And then there's crop rotation, which someone mentioned. So that's the concept of planting, one type of plant like a brassica, and then the next time you're doing next time you might want to do some type of legume, so you're just rotating the crop so that you're not having the same type of plant taking the same exact nutrients every time from the same exact spot, because then you're just going to degrade your soil and you're not going to be able to get much out of it anymore. And plus, there are other ecosystems living there, so you're taking from them as well. And then another way to make sure that things are in balance is soil testing. You don't just do it once to know what your site is like, but you continuously test. So maybe once every season, or once in the fall, once in the spring, and depending on what plants you're trying to learn more about, like if you're doing corn, there's like a time that you would test soil so that you're aware of the next season, or at a certain point within the season, what's going on with the nutrient content in your soil, so that okay, I'm going to plant this cover crop here and I'm going to add these nutrients here, these fertilizers, to make sure that I rebuild the quality of the soil in this area. So you just want to continuously learn about your site, because you can't always just look at something or assume everything is going to be fine or everything is okay. Then there's the concept of watering. So one is knowing your crop. Some things like it to get a little dry in between, like basil. Other plants want to be wet and wet soil all of the time. Some things even like it on, closer towards the waterlogged side, if you're thinking about plants that have developed these adaptations to deal with those weather conditions or environmental conditions, and now it's something that they almost need. But very generally speaking, you want to water fairly infrequently, just meaning that you don't want to be out there watering every single day necessarily, and you just want to make sure that you're watering deeply so that the water is you know, going as deep into the soil as possible and going as far in the soil as possible, because it honestly puts a lot of stress on your plant for it to have this water, and then suddenly it goes really dry and you're like, oh, I got to add more water, and then you're rehydrating it, and the plant ends up stunting its growth. It ends up like killing off parts of the roots because they're not used to having this consistent amount of water. You're just watering it sometimes, or you're watering it every day, but it's not getting enough water, so it's stressed. Another big thing is watering the soil, not the foliage. I know I see people often putting water directly on the leaves. I mean, on a really hot day, like we were talking before about transpiration and that water, you know, the sun energy going to the water instead of the plant, that could work. I do that sometimes. But as a regular practice, I wouldn't do that, because then you're encouraging the growth of molds or something else that you don't really want on your plant, that can end up ultimately harming it. So you really want to water the roots, you want to water the soil, so that the plant is able to actually uptake it, and it's not going to develop necessarily some type of fungus or something it doesn't want on it, that can hurt it. And then keep the water cool. I mean, it's not going to kill your plant necessarily if the water is warm, especially if it's, you know, in a hose and it's a warm day, but I wouldn't put boiling water on a plant. There have been some studies showing like cut flower plants that are in greenhouses, if you put like really, really almost boiling water on the leaves, they're fine, which I'm like, okay. Plants are adaptive, it's cool, but just like generally speaking, try to keep the water cool. And you can also add different microbes to water. Not all plants, the concept of inoculating them, like not all plants can develop those positive symbiotic relationships with every type of microbe, but it still can help just the general health of the soil itself. So you can add different microbes to the water so that you're adding, you know, the water itself as well as additional, you know, helpers, if you will, for your plants. Then there's companion planting is something that you can do, and that's the concept of planting plants that support each other. So again, you're encouraging symbiotic relationships. So in this farm, there was sweet alyssum, there was marigolds, and there are tomatoes. I'm not totally sure if any of these plants necessarily help each other in terms of nutrient content, but generally speaking, when you have flowers, assuming again that they're, you know, these plants aren't releasing some type of chemical that like deters other plants from growing next to it, growing flowers near your plants can help bring in a bunch of pollinators that can help make sure that your tomato flowers are being pollinated, and that you get tomatoes. So, and sometimes you want there to be more space between plants, you don't want them to be crowded, but a lot of the times it also doesn't matter. And they're not necessarily going to harm each other by being that close. So you can do that in this instance. So this is a concept of different species having relationships with each other, other plant species. It's a mutualistic symbiosis, you know, there's like a net positive happening. Usually, you know, both plants have something positive happening between them, but sometimes it might just be one plant is essentially benefiting, but I mean, there are always benefits we can't necessarily see, right? So again, it's like sharing nutrients. It could also offer protection because maybe there's this plant, you know, emits a chemical that like is preventing other things from coming near it, or maybe this plant is attracting a predator that will attack an insect that may otherwise harm the other plants that are there. Again, I said pollinator attraction, and also sometimes if you're thinking again about mycorrhizae as a really good popular example, if you're thinking about trees and how some trees can actually determine which like I don't want to use too many terms, but essentially like what piece of this mycorrhizae or fungus is reaching what plant is actually related to that tree, and share nutrients through it that way, which is really cool. So there's just so many different ways that, you know, you're supporting relationships when you're doing companion planting. And also, again, you want to be very careful about what you're planting next to what so that you minimize competition. You don't want to put two plants that need exactly the same nutrients right on top of each other. So instead of supporting each other's lives, they may be detracting from one another. So it's a very intentional process that you're doing here with companion planting. I'm almost done here, I promise. Then there's plant protection. So this concept of making sure that your plant isn't being attacked by something or too exposed to any one thing. So that's a part of knowing what your plant is. You can deter things by putting down, if you're thinking about like people for like deer and voles and other types of organisms and trying to detract like herbivores, Some people will put down like bovine or like cow blood or like a coyote urine or just something to try to keep something away from the plants from eating them, or reflectors, so like something shiny that like deters an insect or animal from wanting to get, any type of animal from getting to your plant, or moving objects, like the idea of having a scarecrow even. Attracting, like I said in the last slide, natural predators that will attack other insects that may be trying to eat your plant. In this photo, you can see that there's like this cloth over it. Those are row covers. That's allowing the sunlight and water and everything else that it needs to get into there and like gas exchange to happen, but at the same time making sure that like an insect can't get on there and eat your plants. So that's one way you can do it. There are so many other things you can do that are like your own creative methods of figuring out how to do things. Like, for example, in my father's garden, he likes to put down beer in a container and dig that into the soil, and the slugs go into that instead of, because they're attracted to the yeast in the beer as opposed to eating your plants. So, there's so many ways you can support your plant life. And then just using your tools properly. You don't want to accidentally like take a rake because you're not using it correctly and like nick your plant, and then now it's like wounded and now it's like more susceptible to a disease or something, or you just hurt it, so now it can't really grow as well. Then there's also checking plants. So if you're seeing like eggs on a plant, if you're seeing like damage on a plant, so you want to get into the habit of actually looking at your plant. This is from the Colorado potato beetle. These are like little eggs that are just attacking our potatoes, although that's not honestly the only plant that they attack. So you want to make sure that you check them. And honestly, for this process, there were so many of them, and we just took a few days to go around squishing the eggs, and it worked, and our potato plants were fine. Sometimes you want to use like really intensive methods if you're really trying to keep away from using like a pesticide that can, it probably isn't great for you to ingest, that can also hurt the rest of the environment that's there. They're really just, making those observations. Again, that's not exclusive to site assessments. It's also necessary to maintain the health of your plants once they're in the ground. And you might want to use a magnifying glass if you're having like trouble seeing things. I find that to be really helpful as well. And then the last like general thing I'm going to talk about, like our broad category, is just using your tools correctly. Like I said before, use the right tool for the job. You don't want to use something that can create unnecessary damage to your plant. You also don't want to hurt yourself, so you want to keep like the things that are really sharp downward. You don't want to put a shovel with like the part that you're using to actually do the shoveling, like the scooping part, upwards, so that if you step on it, it hits you in the face or can hurt your plant. I mean, either way, you don't want to be harming anyone or anything in the space. And just being mindful of your plants. You don't want to start stepping all over your beds and compacting soil, and now your plant can't spread its roots, or you just like stepped on something and now it's very young and now your plant is dead. So you're just trying to be aware of what's around you and how you're interacting with that space. Other practices, picking up debris if something's damaged, making sure that you're tending to that, properly spacing your plants. You don't want things on top of each other. In this photo, you're seeing interplanting, which you're planting different species. They don't necessarily benefit each other, but they can grow next to each other because their sizes are not going to be so massive that they're impeding each other's growth. So, and they're not using the same exact resources. So it's just like this net zero interaction. But it also allows you to maximize your space, because if you don't have a lot of space for a lot of different plants, like this is one way to get around that. Try to use a diversity of methods. You don't want to keep using the same method over and over and over again, because it may work. But there are other things that may come into play that are taking advantage of the fact that you're not utilizing other methods of, deterring insects or taking care of disease or whatever else. And just give your soil a rest. That concept of cover crops. You don't want to constantly, damage debris just being like if you see like a limb of a plant, like a stem that has fallen off, like you just want to make sure that you're like cutting that so you don't further strip the plant, and just like get rid of that debris. Or if there's disease on it, you don't want a bunch of diseased plants just lying around in your garden, because that disease will spread. So you want to make sure that you're putting that somewhere. Like when there were a bunch of beetles and like mildew on a set of cucurbits that we were growing, at the farm I was at last season, we put them like away from everything else and let it decompose just outside of the site that we were using. That's what I mean by that. But again, leaving your soil to rest, you don't want to keep disturbing something. And then having multiple varieties of the same plant. So some plants might be resistant to one disease and to others, and you're going to find out in your space, in your ecosystem that you're helping to nurture which of those varieties work best. So if something is attacking one variety, but then you still have that plant of a different variety is doing well, you don't lose like all of that crop because of, you know, one instance of one thing happening to your plant. So that's another practice. And then in the time that I have remaining, I want to talk about plant damage, because you can do everything, you know, right. You can do everything that you were suggested to do, and you can still have damage. So I mentioned a few examples, but what are some examples that you can think of plant damage? Insects, for sure. Wilted leaves. Interesting. So here I'm seeing examples of things that cause damage, as well as how the plant responds to damage, which is interesting. And I will cover both of those things. These are great. So very broadly speaking, plant damage can fall into like 3 categories. So there's biological, meaning that there's some type of living organism damaging your plants. Physical can be like parts of the environment, like wind. It can be like you accidentally stepping on your plant. Chemicals, so like these non-living things. So people mention burns, that can be something that happens. So a reaction that's happening. And a lot of these times, I say often, but that's not necessarily true because there's just so much going on all the time. You can prevent this damage from happening, and sometimes you can even reverse the damage, so you don't have to deal with that forever. So I'm just going to go through those. So there's nutrient deficiency, that's a type of chemical damage. So, and because you don't have enough of that nutrient, like let's say you don't have enough nitrogen, and we talked about how nitrogen is an essential macronutrient of a plant. So now you don't have nitrogen supporting like DNA, and you don't have it within all these other different processes in which nitrogen is used often. So you're interrupting a biological process when you don't have enough nutrients available in a plant. So how do you identify that? It's honestly pretty complicated and difficult. I struggle with identifying nutrient deficiencies just by like sight. But there are some things you can learn about each. But you're looking at like, where is the discoloration happening, or where is this note change that you're noticing happening? Sometimes different nutrients will have a plant yellow from the outside in or the inside out. And that's just showing you like what process where is being disrupted, and that's how it helps you just identify it. If the fruits are looking weird, if it's like not growing very tall, these are all some signs that it could mean that your plant is deficient in nutrients, which you can resolve those with amendments. There's a chart you can look at. There's so many charts in so many different places, but I can share this later, that give you some telltale signs of a nutrient deficiency, but ultimately you should just test your soil and sometimes even the plant itself to tell you more definitively if something is deficient. So this is just an example of observing and making those observations. Toxins, so chemical damage, another type of chemical damage. You might have too much of a nutrient and your plant is overwhelmed by that, or you're using a pesticide and it's like it's not being used correctly, so then you end up burning the plant. So again, like looking at the location of where this damage is happening. Is it discoloring the plant? It might affect the fruits. It might impact growth as well. You can address it by putting in another amendment that would help reduce, an overabundance of a nutrient, or you might put something that might accumulate a lot of that particular I guess, toxin of interest. I know there's a lot, I would say that there's conflicting like evidence between what is and is not a bioaccumulator of certain things. Like if you have too much lead in a soil, like some say that plants can't take up any lead whatsoever. There's nothing out there, but then some people say that there are, like sunflowers can do that. But I mean, it's your garden, you can try things out to try to reverse that damage or at least prevent it in the future. There are pathogens or, disease that's biological because it's a living thing attacking your plant. It will be carried by a living or non-living vector, so meaning that it can be carried by an insect, to be carried by the wind, these different pathogens. So you might see, again, discoloration, you might see scabbing on a plant, you might see the fruits acting weird, the plant might be falling or wilting like someone mentioned, and you're thinking, oh, my plant is dehydrated, when really it just has a disease. So the best thing you can do is remove those plants and try to implement better practices and replant some more things in a different area. So you can't necessarily, and I don't know of really any examples where you can reverse the damage done by a disease. If your plant is sick, your plant is sick. Mechanical damage, that's physical. So if you're, again, you step on your plant or, it's really windy and it snaps the plant, I mean, that's also an environmental example of a physical, kind of damage. If you like take a tool and you hit your plant or something, those are all mechanical. So you might have torn leaves, a snapped stem, like in this example, which looks like milkweed. There might be scratches. You can just prevent this by, again, using your tools properly, being careful with your plants. And then you just remove those parts. So you see here, like in this plant, this leaf is kind of hanging off. And if it were to keep, pulling downward, it might continue to strip the parts of the stem, which can expose your plant to disease. So you just want to make sure that you're getting rid of the part that is damaged so that your plant can heal itself and move on. And then second to last one, environmental. So again, another type of physical damage. So that's the wind, it's the sun bleaching your plants, it's water hurting your plants. So you might see bleached leaves like you do in this example. The leaves might be torn, again, snap stems. For this example, someone left their plants out. I was teaching a class and they left them out in the sun over a night, and we didn't realize they were out. So then the sun ended up bleaching these little nasturtiums. So you can just keep them in a better space. And again, like moving the parts that are damaged so the plant can heal itself and move on, hopefully. And then insects, another type of biological living thing impacting plants. So there might be wounds. You can see literal bite marks on this plant. The plants might just be totally eaten. These are our potato plants that I was talking about with those beetles. Scat traces, so if the plant, insects are also pooping as well. So you might see that, which is what's on this plant. So like I said before, you might just literally physically come in and squish the eggs and the bugs, which, is sad, but it's a part of the process if you're trying to maintain your plants. Or you might put down, like I said, other insects you might release. You might put down something called Diatomaceous Earth. That's a way of like using something organic to remove an insect problem that literally like cuts the insects, which is again sad. You might put like an organic spray on your plant. So again, you're using chemicals, but ones that do less damage to like the overall environment. So that is the end of my presentation. And I said so much, so I'm sure you probably have some questions. But since I know we're directly at time, I just want to tell you a little bit about some resources that you can use to learn more, as also just, emailing me. There's Cornell Cooperative Extension. They have so many guides and they can identify different things going wrong with your plants. There are other types of online guides from other sources. You can look at the USDA, other university extension programs. I use information from them all the time, like with Pennsylvania State University Extension, for example. It's a good one because the climates are similar and the information is just good. Internships, you can do apprenticeships at farms directly, farmer training programs. There are so many of those, and that's like growing in popularity, and I know of quite a few. So there's so many different ways to keep learning, and as you can see, there's so much you can know about growing and so many things you can know about plants, and you're not going to learn it all in like one session or one sitting. And it's a practice. You got to keep learning about all these things over time.